Hi, so I'm gonna start a new YouTube playlist called Algos in 10, which means I'll just spend 10 minutes solving an algorithm that's actually pretty cool. The first algorithm to solve today is gonna be the treasure hunt, which is a divide and conquer algorithm. In addition, I want to thank my Northeastern University CS5800 Professor Viola and the summer course for giving me this opportunity to teach to do algorithms. And also, I hope you guys enjoy the summer. Thanks. The paradigm is called divide and conquer. That's it right over here. So you basically divide the problems into subproblems. And then of course, you put them back together via the conquer step or the combine step. These algorithms for the entire playlist will be in different categories. So next time we're going to try some dynamic programming, which is scary, but will help you well out of the interviews. Now let me show you what the problem looks like. Of course, this problem is very, very famous. It's actually very similar to that of very similar problem where we find two things stuck in the middle of some chests. But to make it more interesting, we actually call it the Jack Sparrow and the treasure chest problems. You know, that type of movie was very popular back then. Anyway, the problem is like this. You have a series of treasures chest in an array C. And you're trying to find basically two items for Jack Sparrow. The first item I'm trying to find, of course, is he's fighting Davy Jones, right? And he wants to basically destroy Davy Jones. So mark with index D, C of D, as Davy Jones locker, Davy Jones heart. Also, Jack wants to find something pretty fun, you know, just to get lit or just to enjoy some drinking. A bottle of rum, which we can name of C of R. And of course, if you're not careful, there's a big bad kraken ready to attack Jack. So to avoid the big bad kraken, which we will erase right now, you gotta make sure that it's strictly less than each other. The index of the bottle of rum is strictly greater than the index of the Davy Jones heart. So in a proper divide and conquer, you basically use already an existing algorithm to solve the problem. In this case, we'll use something called binary search. What binary search is basically consisting of is the following. You have an array that has a low element and a high element, and then some element you want to search, X. If in the array X is below the high element, it's like slide to the left, slide to the right, you know, cha-cha real smooth, that type of dance. So you slide or you recurse to the left. If the element is instead higher than a high element, you recurse to the right. And this is something that often people get wrong in interviews, is getting confused of the left and right business with binary search. This problem will show you why, for the threat of Jack getting eaten by the kraken, you should be very careful with this. So let me show you the problem. Oh, by the way, I want to thank LeetCode and also the coding exercise algorithm companies for giving us the opportunity to learn algorithms in a proper monetized way. So for this algorithm, we'll need a divide and conquer paradigm. So let me write out the following. Divide step, conquer step, and then what we call the combine or merge step. So the divide step is pretty easy. We divide what we call the C treasure chests from, for example, indexes 1 to T using a key to to help open the key, to help open the chest, using the key, we divide it by saying the following. We partition the C chests into T potential indices. Continuing onwards, we also have to make sure they're also in groups of 2 when we partition the chests. So I write the following. In groups of 2. Hope you can read that. The conquer step is not that trivial, so we're going to actually make it a little bit bigger. So let's say, for example, Jack wants to just be random and just choose any random, I don't know, close his eyes, plays eeny, meeny, miny, mo, there's a random chest to open, right? So let's say Jack chooses a particular chest with index M. So the chest he chooses is C of M. In this particular selection of chests, we have to once again apply divide and conquer. And the conquer step is something that helps you basically solve the problems that have been split up. In this case, we've only now have a group of 2 chests with M and M plus 1 that Jack could possibly look into. Or you could have instead M minus 1 and M. So you have 2 possible options to look at. Either the increasing M to M plus 1 chest or the strictly decreasing M minus 1 to M chests. Of course, this is the concept of a bitonic point, which is you're trying to find basically the point that turns things from up to down. Just like the Pirates of the Caribbean movie song, Up is Down. Nice little POTC pun. Anyway, if anybody's down to watch that, I'd be glad. It's a nice little throwback in the middle of these summer months. Back to the problem, we have the following. If in between of C of M minus 1 to C of M and C of M plus 1, Jack finds the treasure, then voila, he has returned it. Otherwise, so if he has found it, very good, we just return C of M. And Jack does not get eaten by the kraken. And his black pearl is safe. However, if it's not the case, do we recurse either left or right? Well, in this case, we're increasing by like each index of a chest. So we are obviously going to recurse on the left-hand side. So we're going to recurse on the left. Hopefully that is something you understand. If not, please look at related LeetCode problems in regards to binary search and divide and conquer. Now, the other way around, we're going to see if Jack is clever enough to get both of them in terms of finding the chest that has Davy Jones' heart. We're not yet at the stage of finding the bottle of rum. So let's say in this case, C of M is greater than C of M minus 1 and C of M plus 1 is greater than C of M. So in this case, that means Jack would either have found or not found the chest that contains Davy Jones' heart. So we're still on the Davy Jones' heart part, C of D. If it looks like a 0, I'm going to rewrite this. C of D. There we go. So if he has found it, just return C of M, and that's pretty much it. Jack has found Davy Jones' heart. Yay. If not, we recurse to the right, because now we're trying to basically search on the right-hand side of the array, which is good. So yeah, that's it for the conquer step. That's of course only for the Davy Jones' heart. Now we have to also consider the rum. Well, look at the magic. We use the exact same approach as before, except we just simply substitute for the C of R for the C of D. So for the rum, it's actually super simple. if we have the c of m minus 1 less than c of m less than cm plus 1, you could either return you found it, or you can recurse to the left again, which is the c of r, the ROM. Otherwise, you just do the other way around. C of m minus 1 less than c of m less than c of m plus 1. And you return either the c of m or you recurse to the right. And there we go. That is your conquer step. So hopefully that makes a lot of sense. If not, ask any questions in the comments below. Finally, we end the algorithm with the combine stage. So to wrap up the algorithm, we just have to say basically the combine or merge stage. And that's pretty simple. So basically just put all of the chests together with, of course, Jack finding the bottle of rum, which is C of R greater than the Davy Jones heart, C of D. So yes, this is the rum, this is the heart. And then also return their indices. And there we have it. That is a legitimate application of binary search with the Pirates of the Caribbean and in general, how divide and conquer works. And this is like one of the more basic divide and conquer. It's just finding basically 1 or 2 by tonic points. A better example would be finding a peak finding, which is like if you go to a mountain and you try to find the peaks of a mountain, how would you be able to do that? That's gonna happen in a future episode. But we're not done yet. We gotta always make sure we have the runtime or the interviewer is gonna still think your algorithm is not good. So with a different colored marker, I'm gonna show you the runtime of the algorithm. Sorry, for the note. So yes, the runtime of the algorithm. So runtime is pretty simple. We have basically O of 1 search for each. Search basically yes or no for each chest. And since we partition into like left and right segments for each time we search for Davy Jones heart or the bottle of rum, we have O log of T, which T is the total number of keys we can try to open and close each chest. So the total runtime is a good old O log of T, which means this algorithm is very efficient and you get the offer. So yes, I just want to say these algorithms can be scary and they can be tough. But always, as I learned from doing CS for the Lord, as long as you do the hard things for him, you can easily solve the algos. Check with me next time as we try to solve a very fun dynamic programming problem from Smosh Games called Dynamic Hangman. Have a good night, and remember, up is down. And also don't forget to subscribe. Guys, do not forget to subscribe to my channel, Jason Liu, and also hashtag divide and conquer. So don't worry guys, we know LeetCode and algos can get hard, but I learned one thing this summer, is as long as you're willing to put in the efforts and make it applicable to something that you like, whether it be Pirates of the Caribbean or movies or sports or whatever, I think you'll do great things. So yeah, hopefully people can really enjoy understanding divide and conquer in these tough algorithms in a fun and applicable way. Thank you, and remember to subscribe.